Hey, what's going on there? Welcome back to You Can't Draft. Um, I realized I had the opportunity to make a CADWorx model for something at home because I'm dealing with all this quarantine stuff, working from home. So I figured this would be a good opportunity to see CADWorx in action. Maybe if not a huge structure, but for something smaller at least. Um, I have the opportunity to make a platform. I have some existing models that were created by my electrical department, and we've got an electrical building, two electrical buildings that have two platforms. This platform here is being provided by the vendor, and it's been preliminarily modeled. I don't have to worry about that. This one over here is not provided by the vendor. This transition platform between these two buildings, it's my job to create that. There is a temporary structure that was put here. I'm not sure if electrical created this or somebody else. But I'm not going to follow their format. It's just to go by something that they think they need. I'm going to do something very different here. We have foundations for the buildings, so I can't exactly put um, my columns right on the edges here because the foundations for the columns of my platform will clash with the foundations for these two buildings. So I've already done some preliminary layout here. I'm going to unload these two external references. I've given myself the outline for for the buildings and their correct elevation for the floor. The top of the grading for my platform needs to match the interior floor of these buildings. So that's a seamless transition when you're walking between them. So I've got that all set up. Elevation is set up. I even started preliminarily modeling some beams here. I've gotten that done so far. I'm going to put that back. I did a save as from a previous platform model you can see here um, for a different structure, just so that if I needed to grab anything or use it as a reference, I have that. But I'm probably not going to need everything or anything. I'm going to do this whole thing from scratch. So where this platform, I'm going to freeze this, where this platform was using a combination of channels and angles and some bracing with gussets, this one is going to be using wide flange beams, and I'm probably still going to put some bracing on here because this platform is 9'8" by 15'8", and you can see I've got it to fit neatly in between these two buildings with about a half-inch gap, I believe, somewhere around there. 7/16, that's good enough. It's really, really tight. I'm hoping that this thing fits. I'm even debating about whether I should, scale this back another half inch on each side. But I'm going to get with my engineer on that. We'll determine that. So for now, let's just get this platform laid out. I want to put some channels as my interior or my intermediate beams. Um, it is 9'8" across. I can probably safely get away with some C8s. I thought about putting a beam in the center to cut the span down horizontally, but I think I'll be okay. I had something similar here with about an 8-foot platform, and this used C6s that went across, so I think I'll be okay here to put some channels in. So I'm going to go ahead and draw a line here and copy this over. Let's see, it's almost 16 feet, so we'll copy it over 4 feet. We'll do it every 4 feet. I have grading span that's going to span this way, this north-south. I'm kind of backwards. This is north-south. My grading is going to span this way. I'm using 1.25" grading, which I like to go no more than 4.5 feet. So I'm going to go 4 foot span. So I'm going to use the American Standard channel with a C8 by 11.5, which is the most common size for a C8. Doesn't really matter the towing, but I'm going to tow it this way. And if you look at the actual span between here and here, my delta Y is 3'9", so even less than 4 feet. I'm going to stick with 4 feet, so I'm going to copy this 4 feet, 8 feet, and I think that should get me enough. I'm also going to delete the overlapping line here. And then what's the remainder is even smaller. This is 3'3". So I'm definitely okay for my grading span here. What I say it was, so this one is 4 feet to here and work point to work point. This one is 3'8". So we've got 4 inches to play with. I might be able to move this over. We could do 3'9", 3'9", and 3'9", so they're all evenly spaced. So I'm gonna move this 1 inch, move these two 1 inch, move these two 1 inch, and hopefully this last one is now 3'9". It is. Fantastic. So now we're 3'9", even spacing the whole way across. If I need to come back and put an intermediate beam in later on, I will. So I've already got these coped out. These are my through members. I want to do that because that building is right here, and I want to be able to. I want whoever's installing this to be able to access the bolts. If this goes the other way, let's turn my auto cope off so that I can bring this back to here and bring this one over to here. Let's say it's this way. Let's do a bolted cope. So I'm going to cope, with a bolted cope. So what happens is, this is where my shear tab, we're doing a shear tab connection, so my shear tab is going to go right here. If my shear tab is right here, my bolts are going to be like this, and somebody would not be able to get on this side to attach those bolts. So that's not what I want. So let's undo everything. Okay, and let's make sure my auto cope is turned back on, and it is now. Undoing does not toggle your auto cope back on. It's CADWorx commands are separate from AutoCAD commands. So this doesn't remember that. So I'm going to do a cope on these with a bolted cope on the ends. I cut those back. I'm also going to do an S layer change because I want to use company standard layers. I'm going to change these to this steel pre-issue layer, which is that's what we use before we issue these drawings. Okay. So now that I've got this, I just remembered there's something else that I'm going to want to do, and this will actually affect the spans here. So I have my platform is 9'8" across. I want to cantilever the outsides. I want my columns to be near the center because I want to move it away from the building. So I'm going to start with a column. I'm going to say .z, so I start here. My x and y starts here. So I'm going to start here, and I'm going to take this down to a .z of, I think my elevation will be starting at, let's put 108.6. Actually, it's 0, 0. I put insert on. Oops. 0, 0, comma 108'6". So this line, we'll say at for the xy. This line will go down to here. Now I'm going to put my column in place. So I'm going to use a I guess a 615 column. Only problem with using a 615, let's try 90 degrees, rotated, center, select line. Is that the way I want to go? Yeah, it is. So the only downside to using a 615 is that it is wider than my 818. That's okay though. It's not that big of a deal to go from an 818 to an 824. Doing that will automatically adjust all of my copes, which is really, really nice, and makes it wider than my 615. So what I'm going to do here is bring this a little bit further past. So I'm going to say .y to the outside edge of this column, and then I'm going to bring this a little further out. We're actually bolting. So because we're bolting, this is going to have to come out 3 inches, not half an inch. I'm going to use a cap plate on this. So yeah, I was going to say we should be just wider than this thing, and I don't know why this didn't come to the bottom of this, but we're going to do that now. There we go. Okay, so now we're going to use a cap plate. So I'm going to use the base plate option. Say structural plate. I'm going to put a 1/2 inch cap plate. My length, your length is always the y-axis, so my length is going to be 12 inches. My width is going to be 7 inches. I want it to be 1/2 inch wider on each side in the x-axis, and I want it to be 3 inches on either side in the north-south axis, or the y-axis, sorry. So that'll give me a total of, you have 3 plus 6 is 9 plus another 3. That's your 12 inches. I'm going to use 2 rows of bolts, 2 rows of columns, diameter of 13/16 because I'm going to use a 3/4 inch bolt. my row spacing, so in the row spacing is again the y-axis. My row spacing is going to be 9 inches. I want to be 1.5 inches outside this flange and this flange. So I'm going to put my row spacing at 9 inches. And my column spacing is going to be whatever the gauge of this beam is. This is 824. It's common knowledge that it is a 3.5 gauge, but it actually has been updated. I don't know when, but if you look at the current steelbook, it's actually a 4-inch gauge for 824. It's the only beam to use that, I believe. So now that I've got all my dimensions in place, I'm going to say pick point and choose the end point of this, and it's going to bring that 615 down automatically. It just shortens it up for you. So I'm going to do a match properties on the base plate or the cat plate, and I'm going to do a steel layer change there. I'm also going to make a new base plate. This one's going to be our company standard base plate for W6s. So it's going to be 3/4, 1 foot by 1 foot, 1 inch hole for a 3/4 bolt, and then column and row spacing of 9 to 9 inches. That's going to give me a base plate. Okay, I'm going to match properties there. And if I ID this, I can see the bottom of it is still 1086. All it did was shorten the column up. Kind of like an auto cope in a way. All right, so I don't want this column here. And it's funny, this happens a lot. And I'm kind of glad this happened actually. I did all this work for this beam and realized this isn't even going to be where the beam is connected or the column's connected, because I kind of get lost in a one track, and then I go back and look and realize, oh yeah, that's not what I meant. I actually forgot that here. This isn't what I meant for it to be. I want to move that in. So I have 9'8", so I want to move this in, I don't know, maybe 2'4" would be good. I'm going to do a mirror. I think that should give me enough room for the foundations to clear each other when they do that. So I'm going to bring this back to where it was. I'm going to do dot Y so I match up to this beam here. Now here, what I can do is actually kind of easy. So it's not that bad that I did all this. I can just rotate this. And where this was 824, I might as well make all my perimeter beams 824 now that I'm thinking about it. So again, bring this dot Y up to here. It's going to recope it for me. Now my 824 is wider than the column that's connecting to it. So I'm going to do a rotate. I'm going to choose endpoint for the center line of this beam or this column and rotate everything. And then the column itself, I'm going to actually have to go in here and rotate with the component edit. You don't want to rotate that manually because it won't show up right on single line, or if you change the height of the column, it'll reset itself. So now I can just do a mirror again and we're good to go. So while we're here, I'm going to stretch this piece up so that it looks clean. And then now I can just do a mirror down to here. And there's our 4 columns. So now what I don't know yet, now that I'm looking at this, usually this is how it works. I'll start with the initial design and start to tweak it after the fact. I can see about keeping it like this, but if I do this way, without having a beam go between the columns, I won't be able to do any kind of bracing. And I'm almost positive that the engineer is going to want to see some bracing, because now this long direction is in the weak axis because of the way the column is turned. And he's most likely going to want bracing in this weak axis and just the length of the span. So what I'm going to do is I'm going to move this beam back. Actually, this one has the cope applied to it. So it's if I move this back over to here, it's probably going to cut this beam. So let me try moving it 2'4". Awesome, it did not. So I'm going to bring this here. Nope, it did. Yeah, as soon as you actually do like a resize or something, then it wants to do it. So I'll turn my auto cope off, move it 2'4". Now it won't try to keep that coping plane, which is what I want. So I'm going to adjust here and here. Again, bring this in 2'4" and adjust here and here. Now, what I'm going to do instead, I'm actually going to reset these. So I'm going to type in S-convert solid. I want to reset these coping planes. So I'm going to click all of these. and it's going to reset all their coping planes. And the reason I want to do this is because I want to put a channel on the outside edge of this cantilever. I think that'll work fine. So what do we have from here to here? 2 and 15/16. Okay, so I think I'm going to move this over 2 inches. Actually, I think I'm going to go 2.5. I need to make that gap pretty tight. So let's see what this distance is. 7/16. Okay. Again, if the engineer wants me to move this back a half an inch, I can do that. So 2.5. Now what I'm going to do from here is I'm going to put a channel on the edge. So I'm going to pick a point from, again, the channel has to attach, let's see, not here, but this way. The channel has to be, oops, I forgot my rotation was still on. Here to here. And we're correct. This has to be coped into here so that we can put a shear tab here and they can access the bolts on the sides. So again, I'm going to cope here, 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 and do it bolted. Okay? And then I'm going to do the same thing. I actually can just copy this channel over to, this doesn't look 2.5 inches away. I think I actually need to go 5. I think I did it the wrong direction. I didn't notice that. Yep, 7/16 or 9/16 of an inch, but that's okay. I'm okay with that. I can copy this to here and then just do this flip flange and it puts it back to that direction. Let me measure this platform actually. Yeah, 10'1". That means it's symmetrical. So from here to here should be something 1/2 inch at 2'6.5". Okay. So do my S layer change, S layer change. Okay. And there we are. I'm going to make sure to cope this on this side. Bolted. Now we also have these things crossing. We haven't coped these yet. When I do cope these, it's going to split them. So we can click here, here, and actually, yeah. Let's do that. Let's keep these for now. Again, this design may change heavily once it gets to the engineer, but I'm gonna select these 3 beams and use these 2 beams as my coping planes, and it's gonna split these when I go bolted. You're gonna see I have separate pieces now. That's a great way of doing that. I don't know why these didn't get. Oh, that's right. My auto coping is not on. I remember to keep that on. I'm gonna recope these to here, bolted. And then here, this beam and this beam cope to here, and there we are. There's my coped beam assembly. Now I'm ready for my bracing. So for my bracing, I'm not going to draw the gussets. I usually don't draw the gussets simply because my mic might be a little quiet here. It was like moving around. I actually have a tool for that. I don't have it with me, but I do have a tool, a dynamic block I use to create a template for a gusset. But initially when I'm creating vertical bracing, I don't use gussets. I just use whatever the work point is. So seeing as how nobody needs to get underneath here, we can take the brace all the way to the ground. So company standard for us is to always go 6 inches from the ground. So I'm going to do a dot XY of here. But I want to start down here with my Z. So I'm going to come up 6 inches. Okay, I'm going to say, I'm going to say UCS right. From here, I can say less than 45. And wherever this lands, let's see. Over here, I want to take this down 4 inches because this is a W8. And that's where these 2 are. So let's see, what was this work point? 5 foot 1 1/8. I'm not a big fan of that, and it's because this is a W818. I just realized this has to be a W824. Why didn't you guys tell me that? I'm gonna have to recope and bring this out to here. I did the one side, I did not do this side. So we're gonna cope, bolted, cope, bolted. And this coping plane is still active. I hate it when that happens. And it does happen, where your coping planes will be active still, like old coping planes, and you'll have beams that get split. Turn this back on. Okay. Hopefully that take. Nope. This side got. Okay. All right. Let's look at this thing from the front. I want to make sure that my cat plates are not gonna have issues. What's this beam? 824. I'm okay with that. I'm okay with that. So I believe because the 824 is 7 and 7/8. So I believe this is my 824 here, which you can kind of see go all the way across. This other one here is my channel, which is beyond, so I'm not worried about that. So my cat plates are good. Okay. All right. So back to this brace. I'm not a fan of the fact that it's a weird work point going this way, and I always set my work points in the horizontal first. So let me see what this is again. This is 5'1" and 1/8. So here's what I'm going to do. I'm going to get close. I'm going to put it as a total distance of a 5-foot line. So I'm going to say lengthen command, total, and then total of 5 feet. And then I'm going to click here, and it puts this total line at 5 feet right here. Delta Y, 5 feet, total length, 5 feet. So you can use a lengthen command to set a total length of a line. Whatever side you click is going to make that side shorter or longer. All right, so now I'm going to move this over to here. That's my work point. Oops. Erase this line and do UCS right and trim. I can use this to create my brace now. So I'm going to make this an angle brace. I'm going to make this an L4x4x1/4 because I think that's what the engineer would be okay with. I want to set the work point in the middle of this to be representative of the bolt line. You can't set the work point of an angle to the gauge. It just goes to the center of the angle, which is the half distance. But you can, for representative purposes, you can get the point across. You can always define that in a detail, but for the model, you'll be okay using the center line of the actual angle. So I'm going to set my angle at 180 for a vertical brace. Set the center line location to the center. Select my line. So here's my settings for this. My angle size, my angle rotation angle set to 180, and my insertion set to the center on the outside flange, and then my center line location set to center. When I select line, you'll see there it is. Now you just pick the toe direction. It really doesn't matter which direction you go. For argument's sake, I'll have it toe towards the center. And then I'm going to erase the work line. Actually, I'm not, because I need that work line to measure. Not measure, to make my other one. So I'm going to mirror here. And I set my UCS here so that my mirror works properly. If you don't, the mirror will not work as well as you think it will. It'll want to use the origin point as your mirror axis, or mirror line basically, and it'll be very difficult to mirror something. You have to zoom really far out. So now that I got this, I can reset my UCS, set another brace here, towing the same direction, and I'm actually going to do I'm just going to deselect this, and I'm going to say select similar. I have an alias for that just to make sure I don't have any other lines, which I do here. I can erase that. Before I copy this, I'm going to make sure I don't have the layer set. So I'm going to create a new layer, my personal preference, called VBrace. So I'm going to say new layer. And if this looks kind of silly, it's because I'm using an older version of AutoCAD 2014. You're likely using a much newer version. Even 2016, I believe, looks different. So VBrace. Oh, I do have it created. Why did I think I didn't have it created? I didn't see it a second ago. Oh, because it's white. Let me stretch this out. So I want my VBrace to be 194, which is the color of my other steel, because we haven't issued it yet. Now here I'm not using an S layer change. I'm going to set the whole member to a VBrace layer. I'm going to copy this over, and I'm going to explain why I'm doing this. The reason that I'm setting this to the whole thing to a VBrace layer is that when I go into a plan view and I'm doing a plan view single line steel drawing, I want to be able to freeze the bracing and freeze the center line so that it doesn't get generated with the rest of my steel in my plan view. So I want to be able to hide that, and the easiest way to do that is to set not only the solid but the center line, because the center line is what causes the single line members to generate. So I want to I want to freeze everything. So I'm going to unfreeze everything. So that's why you want the whole thing on that layer. So I have it on the layer that I can freeze. If I were to just like leave it like the other stuff and I try to freeze it, your center lines would stay behind. So there's my bracing set in place in that direction. I don't think I'm going to need bracing in the strong axis. It's very possible. It's also possible he may want to see, the engineer may want to see bracing on the cantilever, but I don't think so. And look, you can see this beam got split too. I'm actually going to, do I want to copy this? No, I'll just fix it. But this is, I don't think he's going to want any bracing here on the outside edge. I'm going to save this real quick. I don't think he's going to want any bracing on the outside edge because this is a complete through member, so it can handle the cantilever. Had this come to like here and stopped, and like this was a through member, then absolutely you're going to need bracing to handle that cantilever because it's pivoting right here. But with this going all the way, it can handle a cantilever of whatever we have here, like 2'4", 2'5", something like that. So I'm going to come back here. Actually, here I can probably just use a steel union. So I'm going to click here, 2 and 3, and it'll bring those back together. They're all the same size and they were sharing the same work point. So those are good. And that's it for the actual steel portion of this. I've got my bracing, I've got base plates, I've got everything I need. Now it's just a matter of grading. This is optional depending on your company. Some places may only do just a rectangular solid offset 1/4 inch. And actually, before I do this, I just realized something that just occurred to me. The top of my walking surface in these buildings is at this elevation, and I set my steel there. So here's what I'm going to have to do. Look at this thing from the front and stretch everything down 1 1/4. I want to say in this case, it's probably easier for me to stretch this up 1 1/4. Actually, it's 1. The height of the grading in this plant is 1 inch. That makes the work point a little closer to the ground, but I think it'll still suffice. If I need to change the work point later, I always can. Now that I've stretched those up, I'm going to move the whole thing down 1 inch. And now I've got room for my grading. So I'm going to go ahead and draw that grading here. Change my UCS back. And I'm going to offset 0.25. I'm going to move this off to the side about 20 feet, a little more, we'll say 30 feet. Okay. Now I want to make a hatch inside this at this elevation. So you have to set the UCS at the elevation of the P line. If you don't, then the hatch will get set down at 0 elevation. A hatch is always going to be set wherever your elevation is at. So I want a hatch here. I'm going to go to the hatch, pick my pattern. I'm going to go to the other predefined tab, go to the grading preset, or the grate preset. I'm going to choose a scale of 32, which gives me really, really accurate as far as grading size. It makes the spacing on the grading 4 inches long, which I like. I'm going to select my objects, hit OK, and then I've got my grading in place. Actually, I have the span the wrong way. I wanted to span the other direction, so I'm going to change the span from 0 to 90 on my grading here. That way, it spans the north-south direction. Now I'm going to explode it, and if you look and I go measure this, if I measure each one of these, it's 4 inches. And in this direction, it's 1 inch, which is honestly exactly what I want it to be. So this could be representative of the grading. What I like to do after this is do an MP edit, select everything, and change it to, it's going to ask you to convert lines and arcs to polylines. Say yes. Now that they're all polylines, I want to change the width of them to 3/16 of an inch, which is what the grading will be, 3/16 of an inch thick, so it looks like this. And then change, select everything again, go to properties and change the thickness, which is the height, to 1. That's going to give me a physical height for everything, okay? Actual bars. In real grading, this perimeter bar will not be here. It'll be like this, but I always like to keep it there and leave it there, even though it's not like real life, because if I ever have to redo the grading, I can just modify that polyline again. So Now that I got everything here, I want to group it and put it on its respective layer and move this back 30 feet. So there's my grading. Okay. Lastly, I'm going to do my handrail. Now the handrail is kind of another beast entirely. So if you're doing pipe handrail, it's easy to make a profile that works for this whole thing. But the thing about the handrail tools, it always wants to put pieces at the very ends, and you likely won't have like posts, and you won't have posts at the very end. What you're going to have are like here on, like for example, this corner. If I use the handrail tool on this corner, it's going to want to put a post on the corner. That will never happen. You'll never have a post on the corner. You're going to have a post on the just before the corner. Now in this particular case, I'm using angle piping, and it is angle handrail, and it is going to have to go on the sides. I've already done something similar on a previous, and this is what I was talking about, where I can grab something from a previous structure. So what I can do here is grab this angle and move it from here, and I'm going to grab everything. Actually, this whole piece is all one thing. I can just detach it later. So I'm going to move it from here. Let's see, this would have been the outside edge of my angle handrail. Oh, my graphics are starting to wig out on me. Let me try this again. So I'm going to put that right here. Now the only thing I have to do at this point is just kind of tweak it. I'm going to ungroup this because I had it grouped. I'm going to erase the pieces that I don't need. I don't need this post. And I'm going to put a stair right in the middle. So I'm going to offset 1'6", and then probably another 4 inches for my handrail for now. I'm going to change the orientation of this angle to 90. Yeah, perfect. And then I'm going to put this angle right here. That's going to be the edge of my handrail. That's where I want these to stop. So when I come back on these angles here, I want these angles to come back to this point. They overhang because I had a previous miter. I'm going to remiter these, and actually I'm going to also take this, and let's see, what's the distance between here and this edge of this building? 1'4". So I'm going to bring this back 1'6". And that should cover this handrail. Now I'm just going to miter these, and that'll reset the miter here, that overhang. When I do a miter with these two angles, it'll reset this, because now it's only applying a miter at the corner. Okay, these are all good. And I think that's good for that. Are these on the handrail layer still? Yeah, let me put the handrail layer back to yellow, which is what I had it before, so that I know I'm working with handrail. Okay, so it might be something more realistically like this. I'm not going to go super accurate with the handrail because the detailer who's detailing this out will figure out the handrail, but I want this to look somewhat similar to how it might look in the field. There may be a piece over here like this, maybe a couple feet, or maybe another 6 inches, something like that, but that should be good enough. And then, so I want to copy this. What I say? I did 1 foot, so 1'10". I did 1'6" plus 4 inches, so I'm going to go 1'10" this way. And I'm going to do the same thing where I'm going to copy this over to here and change this back to 0. And then copy this. Let's see, what's the distance from here to here? That's 6'9". I'll copy this 6'8". That'll get me pretty darn close. And then I'm going to copy this from here. Actually, I need to copy all of these because I got the toe plate in there. Over to here. The thing about mitering is that when you stretch a member that's been mitered, it keeps the miter. So everything's stretched back, but it keeps the miter. So to reset these, I'm going to use that S convert solid. Here, here, and here. And this one didn't do it. Miters are kind of hard to get rid of. Sometimes to get rid of a miter, you actually have to change the member size and then change it back. They can be a little tricky to get rid of. So 316, and I'm using 2.5 by 2.5 by quarter as my chosen size. Okay, so that's good enough. That's good enough. And there we go. There's my opening. My stairs are going to go right here in the middle. So for the back side, I'm going to steal this one. I'm going to ungroup it first, and I'm just going to move these pieces from, heck, I'll just go from the center here, or the outside edge, which is this, to the outside edge of this. And there we go. And again, like I said, this actually may be even pushed back here, and I'll have like a cantilever. If it's on top, it won't be posted on top. If this were a top mount, you wouldn't have a top mount post right here. It would absolutely be a post. It'd be a post, but you'd have a gap. It wouldn't actually connect to the ground, to the beam like this one would. But since I'm mounting on the side, I can kind of fake that in. So let's do this. Let's take this one. Same as this. And I'm actually going to take this here and put it in the center so that we have like a 3-post looking thing. And then I'm going to rotate this to 270 maybe, or 0. No, 270 works. So what's my distance from here to here? Oops. From here to the edge of the platform. 1 1/8. Is that what it was last time? Was it 1 1/8? Delta X 1 1/8? I guess it was. Okay, which is fine. Honestly, it doesn't have to be perfect. Handrail is representative. Unless you're detailing handrail, then you really got to make sure your numbers are accurate. So what's this? 2.5. We'll take you 1'11". Actually, let's just measure this. What is it from here to here? Ooh, I don't like that. 4'10". Let's make you 4'10" and 1/8. I'm gonna make it 4'10". All right, same thing here. 4'10". I just realized I had this thing centered on the center of the angle. 4'11.25". Yeah, that's right. So offset 4'11", one way, 2 ways. And there we go. All right. So I'm going to go from the top, stretch this to here, stretch this to here, and that's good enough for what I'm doing. Again, to get rid of this and get rid of this. To get rid of this little silly overhang, you kind of just got to double click and reset. Same thing here. There we go. And this thing mitered but kept its kind of goofy overhang as well. So back to 1/4 inch you go. And it got rid of the miter, which I'm gonna, you don't have to have a miter for these, but I do. All right, that's it. That's it. That's it. Let me get rid of this one. There's our handrail. I'm not gonna do the stairs in this video. I actually have a block for the stairs, and I don't use the stair tool. I don't know if I've ever mentioned that in my previous CADWorx videos, but I don't use the stair tool. But that's essentially the platform. So now what I'm going to do is I'm going to load in let me save this first. I want to load in the models that I had before and try to freeze uh, their platform. Reload these models. Okay, so let's see if I can freeze their foundations, models, stairs, all that stuff. Okay, it kind of froze the bottom of their building too, but I think it's okay. So let's go ahead and turn this thing to a realistic visual style and then kind of orbit around and see how we look. Yeah, we're clear of the building here. Our handrails clear the building here. We're really, really close, but you can see that we're there. We really don't want to have a gap here. We don't want to have any kind of a hazard where somebody can slip through. Um, I mean, I think it's close enough to where we don't need a toe plate here. No tools or anything's going to fall through these gaps, but it's not like anybody's going to be below here anyways. So we're close. We're tight fit. That's what we want to be. But, everything lines up. Um, yeah, this isn't being. There's a perimeter channel missing. Um, you can see it right there. So we're like right up against that. Oops, let me freeze this. There we go. So I think we're good. This thing looks good. I'm happy with it. So there we go. That's fitting a platform in between two buildings. It's tight spaces, but it works. It's not the prettiest looking platform, but that's because looking at it by itself looks kind of silly. But when you look at it within you know the context of being between the two buildings, I think it works, and I think the engineer will be okay with this. So, all right, thanks for watching.